So welcome to our webinar on productive discussions in science. My name is Michelle Tyndall, and I'm a facilitator for professional learning here at Activate Learning. My background is that I taught for about 26 years at the high school level, teaching chemistry and physics, and then I spent some time as a science and math curriculum coordinator, and now I'm working with Activate Learning. So it's my pleasure to be with you tonight and to talk a little bit about productive discussions in science. As we're making the shift to three-dimensional instruction and putting students in the role of figuring out in the driver's seat of their learning, discussions become really, really important for our classrooms. So we're going to dip our toe into that today and how it relates to our three-dimensional teaching and learning that we talked about last month. So we'll do a quick little recap of that three-dimensional teaching and learning and dive right into our productive discussions in science. So in the chat, I'm going to put a link to our Jamboard. We'll be using that shortly. So if you would go ahead and open up that Jamboard, we'll use it, as I said, in just a little bit. So with that, I'm going to go ahead and share my screen. We're going to have an interactive webinar today. So not a sit and get by any means. I want you to have an opportunity to engage with each other and with me and with the content of our webinar tonight. So I'm going to invite you to be using the chat. So if you want to go ahead and have that open and then also use the Jamboard, we'll be able to interact with each other and get some nice collaboration going on during our session tonight. So with that, I'll go ahead and share my screen. And here we are. So you should see my title screen here. And if you can just give me a little thumbs up emoji in Zoom if you see it, or let me know in the chat that you're seeing my intro screen. We're going to Perfect. We're going to go ahead and get started, but I wanted to leave you with my email address. You should have seen it in the welcome registration, and it's also here again. So if you have any questions as you're moving into using productive discussions in science or about the use of OpenSciEd, which we're going to be using as part of our activity today, please feel free to reach out to me. My email address is mtyndall@activatelearning.com, and I'd be happy to collaborate and chat with you going forward. So if you would, please introduce yourself in the chat. So if you would give your name and where you're from and what grade levels or subjects you teach, or if you're not in a teaching role, if you could let us know what your role is, that would help us build our community of learners for tonight. So go ahead and take a minute and put your intro into the chat. Yeah, and if you could let me know what grade levels or subjects you teach or what role you play in the schools, that would be helpful as well. Okay, so I see some 6 through 12 folks. Great. Curriculum coordinator, welcome everybody. It's nice to see a diverse group and coaches. So this is great. We've got chemistry here, biology and chemistry. Curriculum coordinators, awesome. So we have a nice wide variety of groups. Physics I see coming in here. So it's nice we'll get some good voices and from a lot of different roles in the schools today. So it's nice to see that in the chat, and welcome to everybody. As I mentioned, my role was teaching and then curriculum coordinator, and now I'm a facilitator for Activate Learning. So it's great to see everyone here tonight. So with that, let's cruise on into our activity for today. We're going to get started right away, and we're going to talk about what's your why, right? So why is it important for students to discuss in science? And then what's your biggest challenge with science discussions? So if you could just take a minute on your own, I'm going to set the timer, and you'll see this little prompt for what we're going to be doing. So we talk about the alone zone. Oftentimes we want students to have a chance to consolidate their thinking before they have to talk in front of everybody. So the alone zone gives them that quiet place to collect their thoughts before they're doing a turn and talk, or before they're taking it to their small group or to a large group. And what we find is that giving students that opportunity to think first helps them feel more confident in sharing. It gives them something to look at when they are doing their talk. And then it also helps them to feel like they're able to share their thinking in a way that makes sense because they've kind of thought through it in their head first. So I'm going to give you about a minute. And what I'd like you to do is jot down your thoughts on those two prompts. Why is it important for students to discuss in science? And what's your biggest challenge with science discussions in your classroom space or in your work role that you're in? And then we are going to take that to our Jamboard. So I'm giving you a chance to think first, and then we'll share second. So I'm going to set our timer, and then we will come back together as a group in about a minute. Okay, I'll welcome everybody back to our presentation here. So if you would, again, if you have not joined our Jamboard, here's the link in the chat. I know that I put it in earlier, but as people roll in, we'll need to keep adding that in there. So on our Jamboard, you'll see in frame 1, we have why is it important for students to discuss in science? So if you've not used Jamboard before, you'll notice that there's some tools over here on the left. And right underneath the big arrow is this little Post-it note or a sticky note icon. So when you click on that, it'll give you a sticky note window, and you can pick a color and put in your thoughts on why is it important for students to discuss in science, and then just click save, and it will pop up your sticky note onto our page. So please go ahead and join us in adding in your sticky notes. Okay, we're getting lots of really good ideas, so keep them coming. I'm just moving some things around, and you can as well. If you see some Post-it notes that are along the same lines and thinking, so feel free to move yours kind of and clump them together by some common things. I started with a collaboration theme here in the center here, making students thinking visible and assess their understanding. Collaboration again. So if you see a spot for your sticky note or for one of the ones that's already there, feel free to slide them around. It's one of the nice parts about using a whiteboard with some sticky notes on it. We can move things around. So taking a look at some common themes that I'm seeing here. I'm seeing collaboration. I'm also seeing 2 or 3 notes here that are about making students thinking visible, to assess their understanding, to a better way to find out where their thoughts and perspectives are on things, help students explain their reasoning, and to communicate their ideas based on their evidence and their data. So there's lots of good reasons that we're seeing here. And I want to call out another one that I just happened to move around here, that the students that are doing the talking are the ones doing the learning. I'm just going to pause on that one here for a second. So certainly all of these things are here, but when the students are doing the talking, they're the ones that are doing the learning. So I want you to kind of keep that in mind as we go through this evening. It's a very important skill that we're going to ask our students to do. And when we're having students talk, we're really giving them a strong tool in their toolkit for using in their coursework, but then also using in their everyday life, and a communication skill that they will use as they leave us and go on into their future roles and careers after they leave our schools. So lots of really good reasons for having students to discuss in science. Although we know all these great things and these reasons for discussing in science, it's often really hard. And it gets harder as you go from elementary to middle school, and then sometimes even harder so when you go from middle school into high school. Students are used to coming in and getting some information, maybe answering some questions, and then going ahead and going on to their next class. So I want to take a second. If you flip over to frame 2 in our Jamboard, you'll see what is your biggest challenge with science discussions. So if we could do the same, put on a sticky note, and then start to kind of move our sticky notes into some common threads of what we're seeing in terms of challenges with science discussions. So go ahead and add in your biggest challenges with science discussions. Silence and crickets. I've heard that in so many locations, right? Students afraid of being wrong. That's huge in our secondary schools. Right, students have a reluctance to speak. They didn't do or prepare alone, and so they also didn't do the prepare alone, and they're thinking to participate. Some of the challenges: keeping the conversation respectful when students disagree, right? And that's something that we have to help our students with as we're entering into discussions. Students are afraid to share, and it's intimidating for them. Good. Facilitating the conversation. So I'm guessing that's as in the teacher role, facilitating the conversation and keeping a flow. We've got another one, coaching teachers into having students practice specific talk moves and not wait until weeks after school begins. Great. Participation inequality. Some students dominate and lack confidence. I'm sure everybody has had those 5 students that you're asking a question and they have their hand up almost before you even finish the question. And it's the same 5 students or so that are trying to be the ones answering those questions, and everyone else is sitting there. And as one of our sticky notes says, you've got crickets from everyone else. Students feeling that they're not good at science, varied levels of understanding and different levels of prior knowledge, trying to get students to stay on topic. So we're seeing lots of different challenges to having these discussions in science. And I want to springboard off of actually one of these that came across in terms of starting it at the beginning of the school year and not waiting until weeks after school begins. So I know we're in the middle of summer, but across the country, we've got folks who are going to be going into their classrooms in the next 2 or 3 weeks and then starting class at the end of July, beginning of August. And so as we start thinking about discussions in science and discussions in our classroom and all of our challenges, think about how you're going to start the school year, right? How are you going to start the school year to foster some of these things, maybe get ahead of the curve on some of these challenges right from the start. So you'll notice when we started today, we started with an opinion piece. Loretta says our district started today. Oh my goodness, Loretta. Yeah, starting today. That's a thing. My goodness. Whew. Can't even imagine that. We just got out about a month ago here in Michigan. So we're sort of in the middle of our summer break. So as your sites turn to starting your school year, think about how you can set up your routines, how you can start practicing the talk moves and making them part of your culture. We're going to talk about talk moves here shortly. And then how you can build your learning community so that you're really leaning into some of these things that would be challenges before they become challenges. So thanks for sharing some of your sticky points with discussions. It is very real that our secondary students are afraid of being wrong, that they are used to doing school and want to have the right answer. And this idea of figuring out and not knowing yet is very, very uncomfortable for our students. And as teachers, sometimes it's uncomfortable for us to address the wrong answers and work the students into an understanding. And it's something that's new, to be that facilitator of the understanding before this, while the students are doing their figuring out. So thanks for sharing all of your thoughts here on the challenges. And we're going to work through some of these as we go through tonight. So I'm going to cruise back to our slideshow here. And if at any point when I'm flipping screens, if you're not seeing what I'm talking about, please throw it into the chat and I'll make sure I change up on my my sharing. So take a look at our intro to productive discussions, right? So what are we going to be doing today? We're going to take a look at the introduction about why are we even having students talk in the first place. So we're going to revisit our three-dimensional learning just enough so that we have some common vocabulary, right? So we know in the NGSS or in many of your states, you have this interwoven three disciplines, and they might come by different names, but in the next generation science standards, you'll hear disciplinary core ideas. That's the what students are going to be learning. That's our content. The science engineer practices, those are the verbs of science. And we're asking students to do a lot of the science, the active science, and lean into using these practices. So as they are trying to figure things out, they're doing the investigations, they're analyzing the data, they're making claims, they're arguing from evidence. And then the cross-cutting concepts are those lenses that we use to examine science content and a phenomenon, for example. So those would be things like structure and function, energy and matter, cause and effect, patterns, systems. So all of these cross-cutting concepts are things that we could really use to look at any scenario or a phenomena as students are looking at figuring out science. So why do we have students talk? So that they can use the practices and cross-cutting concepts to learn the content. And they can also make use of the content as they learn how to do the practices and look at cross-cutting concepts. So we see this kind of woven rope together. You can't really learn one without the others. And they really are sort of dependent upon and having equal status right now in the NGSS. So here you'll see a graphic from NGSS at NSTA. And I want us to focus really on the center of the Venn diagram. And what you see here are the practices that are in English language arts, the practices that are in sciences, and the practices that are in math. And when you look at the center, you see read, write, and speak grounded in evidence for ELA. You see math, construct viable arguments and critique the reasoning of others. And for science, engage in argument from evidence. All that involves talk and communication. So for our students to be mathematically literate and literate in the English language arts and literate in science, they really have to lean into this idea of talk and this idea of communication. So I like this graphic just so that we see that we're not alone in science and asking students to do these things. So if you can lean into this idea of talk across the curriculum, it will be a powerful, powerful tool for your students across all your subject areas. So we're making the shift of students learning about science to figuring out. Students will have a phenomenon, or they'll have something that they can't explain yet, or they have to come up with a design solution of some sort. And we're asking them to figure out the solution or figure out what's happening with a phenomenon that they can't explain yet. So what can you do to move more toward that three-dimensional teaching and learning? We talked in our last webinar about beginning with an anchoring phenomena, grounding the new learning in evidence from students doing science, and put students at the center of their learning. All of those pieces lean heavily onto students being able to discuss and collaborate as they're trying to figure out this anchoring phenomenon. So keep those pieces in mind as we move through tonight. We're going to talk about our students trying to figure out, and this classroom community of learners figuring out as a group, our students are grappling with new ideas. They're communicating their current understandings. They're building from each other's ideas, and the teachers are facilitating these discussions to guide students in their learning. So that shift from tell the students what they need to know and then do an investigation is now put the investigation up front and help students figure it out through collaboration, through their talk, through you finding out what their thinking is through discussions and questioning, so that you're able to facilitate those discussions to guide them in their learning. So what you'll see here is we're going to take a look at just the beginning part of the Talk Science Primer. And I'm going to put that link in the chat as well. So you can open that up and take a peek at it. So there's the link to the inquiry project. And the Talk Science Primer is work that was done by Sarah Michaels and Kathy O'Connor. And when you take a peek at that document, go ahead and open it up. And you'll see this first page talks about what is academically productive talk, and isn't all classroom talk productive? And oftentimes when we go into classrooms or we observe classrooms, students talking could be the norm, but is it really academically productive talk? And what's the difference between lots of talk going on and moving towards students figuring out and helping them to really solidify and make sense out of their experiences? So I'm going to give you a few minutes, I believe about 3 minutes, to start reading on this page number 1 of the Talk Science Primer. And if you have extra moments, go ahead into page 2. And then we'll start to kind of tease apart some of the things that are talked about in this. If you have a chance to read this at some point, it really does give a nice foundation for engaging and talking in your classroom. So with that, I'm going to be quiet for about 3 minutes and give you a chance to read through at least the first page, if not the first and second page of the Talk Science Primer. And again, let me put that link into the chat for you, and there it is. So I'll set the timer and I'll be back in about 3 minutes. Okay, so we're going to come back together as a group. And if you would, in the chat, I'm going to have you type out an aha or a takeaway from what you just read, but don't hit enter just yet. Okay, so in the chat, type an aha or a takeaway that you got from that little bit of reading, but don't hit enter just yet. I'll give you about a minute or so, a little less than a minute, to type in what was one of your takeaways from the part that you read. And then in about 20 seconds or so, I'll have you hit enter so we can take a look at everybody's thoughts all at one time. Okay, please go ahead and hit enter. Okay, I'm seeing some great takeaways here. The 4 different discussion types. Plan your questions to frame the discussion. Avoid your initiation, respond, and evaluate. Deep understanding of the content, which unfortunately not all teachers have. And then for the 7 elements of productive talk, most require practice with lower stakes topics. Good. Deliberate planning. Avoid saying yes or no. Have students counter talk on their reasoning with peers. Students are motivated to speak and want to go public, have to cultivate this with intention. Yes. So we've got some great thinking going on and some nice takeaways from this article. I want to kind of elevate a few of these. And several of you mentioned the planning part that goes into this, and also cultivating your the talk that's in your classroom. And if you remember from our Jamboard, we had a lot of that. Practice it with your students and to make that part of your routine from the beginning. And I want to highlight one of the comments that was in our chat, to require practice with lower stakes topics. The more you can at the beginning of the year get students comfortable talking about whatever it is they're comfortable talking about, whether it's getting to know each other, whether it's something about what they did over the weekend, whether it's some happening that might be going on in the school, or a position on something that is of interest to them. You know, what is your favorite, and fill in the blank. Doing that at the beginning of the year and having them make connections to each other and starting to build that learning community is so very important. They're not going to want to talk to each other unless they're comfortable. And as we saw on our Jamboard, being comfortable talking and sharing is a huge hurdle and a challenge to our discussions in science. So think about in the beginning of the year, what can we have students talk about that they actually like to talk about, and then transition to the more sciencey discussions after they've had a chance to talk to each other on some low stakes thing. And then also in the chat, there was a comment, I believe, let me just find it real quick, where we want to make sure that we are really being intentional with what we're doing with our students and practicing that with them. And I've said it before, I'll say it several times tonight. The students aren't going to engage in this kind of talk unless you are as well. So if you want them to add on to somebody else's conversation or statement, ask them to add on early in the year so that they'll start doing it on their own later in the year. Similarly, if you want them to explain with reasoning and give their evidence, ask for that early on so that they will do it naturally later on in the year. So it's all about like setting the stage and the expectation through your questioning early on, and helping students get used to that talk through you modeling that for them. So let's cruise on with our content for this evening, taking a look at our elements of academically productive talk. A couple of you mentioned this as we were doing our little chat stream there. Believe your students can do it. If you scaffold the learning and give them investigations and activities where they can put the pieces together, they can absolutely do it. Have well-established ground rules. In our Jamboard, somebody mentioned that students have difficulty disagreeing with each other and staying respectful in that space. So again, at that beginning of the year, when you're launching your classroom, establish those, like co-create those so that the students have buy-in, so that they all know the ground rules, and you can keep referring to them during the school year, especially at the beginning of the year when you're trying to establish your learning community. Clear academic purposes, like what's the reason for our talk in the first place? A deep understanding of academic content. And as teachers are moving around from grade level to grade level, from subchair to subchair, sometimes this is a hard one. And it's really uncomfortable for teachers to have students engage in talk when they might not be as familiar with the content area. So that one is one that we need to work on. And know that just as students can be okay being wrong and not knowing the answer yet, it's liberating when teachers get to that point too. You know what? Let's figure it out. I'll check that out if you don't know it. So, but it's a hard space to be in as teachers. I totally understand that. Framing questions and follow-up questions. How are you going to frame the discussion? If you ask a narrow question, you're going to get crickets. If you ask a framing question that is deep and offers lots of different perspectives, you're going to get some good conversation. So think about your initial framing and what you're asking for your discussion, and then find those follow-up questions for an answer. As somebody in the chat mentioned, avoid saying yes or no, like, oh yeah, great answer, and then you just move on to the next thing. How can you have that follow-up question of what's your evidence, or how do you know that, or can somebody add on? Can we clarify on revoicing? So think about what your follow-up would be. Appropriate talk format. So what is it going to look like for our discussion today? And a set of strategic talk moves, and we will talk about those talk moves. You've now heard the talk moves twice, so I'm going to just leave the anticipation there for a little bit longer. And why is it important? I'll give you a few seconds to kind of read through this. This is all coming from the Talk Science Primer with O'Connor and Michael's work. So taking a look at why are we having students do the talk in the first place? Okay, types of discussions. You're going to find that when you open up different programs, each one is going to have their own little blush on the words that they use for discussions. And in the Talk Science Primer, it talks about 4 different types of discussions in terms of how we're going to interact with data and coming up to agreements and having consolidation discussions. In Open SciEd, which is what I'm going to use for my examples today, they're going to talk about 3 different broad categories of discussions. So if you think of an initial ideas discussion, that's your brainstorming. It's the middle of or the beginning of an activity or the beginning of your unit. You're getting out students' ideas. And it's a great time for you to figure out what your students know and don't know and kind of what they're thinking, maybe some misconceptions. Building understanding discussions are going to help students make sense of what they've done. It helps them kind of put the pieces together, if you think of it that way. We position them to do investigations. The building understanding discussions help them make sense out of what we've just asked them to engage in terms of an investigation and make sense of the data and observations that they've made. Oops, sorry. And then the consensus discussion, right? So after students have had an opportunity to wrestle with a lot of information and start to build some understanding, we want them to land on the science, right? And the scientific principles. And when they're figuring out, we want them to figure out the academic vocabulary and the principles that are part of the rich part of our content. So the consensus discussions are where we're going to really land the plane, so to speak, on that level of thinking. And when we're developing models, we have groups making models, individuals making models, and then this is the time to come up with that, what we agree on and what we don't agree on, and what we still have questions on as we're moving through our units. So as I mentioned, the initial ideas discussion is all about eliciting students' initial ideas. If you pull back the curtains on your instruction and let your students know that we are in an initial ideas discussion, their stress level is going to go way down. So remember those challenges on our Jamboard of students being afraid to participate? If they know that we're just getting ideas out and we're brainstorming and we're coming up with everything we're just going to share, they're not going to feel the need to know the right answer. So I challenge you to kind of pull back the curtains for your students to let them know what kind of discussion they're having so that they know that it's okay to not know yet, right? So we're going to pop into a unit from chemistry of OpenSciEd. Activate Learning is a partner with OpenSciEd, so we deliver their content. We curate all of their resources and materials for their curriculum. We also offer professional learning for teachers, and we offer kits for it. So we're going to talk about the anchoring phenomena from seed 2, which is the beginnings of atomic structure in OpenSciEd. So we're going to take a look at video. And where is the lightning going from and where is it going to? So I'm just going to have you watch the video real quick. And then we're going to put our student hats on here for a bit and take a look at this little video here. So let's take a peek at it. Okay, so maybe think of, and if you need to jot down, where's the lightning going from and where's it going to? In your notebook or on your device there at your desk or wherever you happen to be at, make a notice in a wonder chart. What do you notice and what do you wonder about what you see in the slow motion videos of lightning? So jot down what you notice and what you wonder in these videos of lightning. Okay, so into our chat, okay, we're going to have our initial ideas discussion of sorts. And just getting out your ideas of what do you notice in the videos of lightning that we just saw 3 different videos. So the very first one, and then we saw this one, the slow motion one here. And we saw that slow motion one. So into the chat, jot down what you noticed. So what did you notice? Let's have our initial ideas discussion. And you can go ahead and hit enter whenever you get yours put in. But what do you notice in these videos? Go ahead and put it in the chat and hit enter. Okay, so we've got lightning spreads out into webs and it has different shapes or structure that it seems to move from side to side. We have some areas of the lightning stick are more intense than others. Good. Like some residual or perhaps some smoke. Lightning branches. Okay, so if we were in our classroom right now, students would be coming up with all these and sharing them with the group. I, as the teacher, would just be literally jotting it down as their scribe. Lightning looks like a branch in the sky. Okay, so we've got some good noticings of what's happening with lightning and what it looks like. So great, thanks for sharing your initial ideas. We would also ask students to share what they wonder in a similar way in terms of an initial ideas, like what are you wondering about this? As we move through the initial anchoring phenomena routine in Open SciEd, there's lots of places where we ask students what they wonder, which is a switch. Very rarely in traditional curriculum did we ever present something to students, say, hey, what do you wonder about this? In Open SciEd, we do that a lot because that's what happens in science. We see something, we can't explain it yet, we wonder about it, we ask some questions. So in our discussions, we're going to ask students to do the same things. So a building understanding discussion, this is where they're communicating their understanding. In our Jamboard, folks were mentioning, like, you can really have students make their thinking visible. They can identify and make sense of observations, and they can make claims based upon the evidence that they have collected, whether it be observations or data or some sort of information that they're looking at. So in this sort of a discussion, you're just helping students make sense is the big idea here. Again, we don't know yet. So when I talk about, opening the curtains and letting students peek behind the curtains of your instruction, let them know we're in a building understanding discussion and we don't know the answers yet. And it's okay to just kick out your ideas because we're going to try and make sense out of it. It's not a time where you have to have the right answer. We're just asking for, what do you think? And do you have some evidence to back it up? So I want you to take a look at these graphs here. And in the graph, you will see the green one talks about seasons in the x-axis, and it has millions of flashes along the y-axis. The blue bar graph has got months, so it's showing each month of the year along the x-axis, and then millions of flashes on the y-axis. And then the red bar graphs have weeks of the year. So for each of the weeks of the year, there's going to be a bar and millions of flashes on the y-axis as well. So we're not going to do a turn and talk right now, but I am going to ask you to do a quick write. What do each of these graphs show? What patterns do you notice across the graphs? And what questions do you have about these data? So take about a minute right now and go ahead and jot down, what do each of these graphs show? What patterns do you notice across the graphs? And what questions do you have about these data? Okay, we're going to cruise on to the next one. So I'm going to have you look at some more information. So where does lightning occur in the US? So taking a look at the key at the top, it's flashes per square kilometer per year. And we've got the map of the United States. And I want you to add to your noticing and wonder chart, what do you notice? Okay, so what do you notice here? Take a look at the key, take a look at the map, and add to your notice and wonder chart. Okay, let's take a peek here. So this is looking at the mean lightning flash extent density, so the number of flashes visible per 100 square kilometer pixels per day. So taking a look at where the lightning does occur in terms of our global perspective. And then we can take a look at, with our class, we would be then having a building understanding discussion to try and figure out, again, remember that figuring out part in our building understanding discussions, what factors seem to influence where or when lightning occurs, and how did looking at different data and scales of data help us? So we're going to put on the students to try and use some information and sift through it, but then talk about it, right? So that's the big idea, that you're asking students to talk. You're not just giving them the factors. you're having them discover those factors, but doing so as a collaborative group and having some talk going along with it. And your role would be to facilitate that talk. So our last of our discussion types would be a consensus discussion. We all want our students to walk away at the end with some way of explaining the relationships, to develop a model that predicts and explains our observations, and to come to a consensus on the scientific principles and the new words or the academic vocabulary that we have just earned and generated as part of the investigations. So I want to take a peek at a classroom discussion. And in this classroom discussion, like, what is the teacher's role and what is the student's role? And then how does the teacher move the students thinking forward? Okay, so think of those three pieces. What's the teacher's role? What's the student's role? And how does the teacher move the students thinking forward? So let's go there. We're going to watch this for about 2 or 3 minutes. And then we'll have a quick entry into our chat about it.
When you started to draw your model of what causes lightning, what were some of the components? What were some of the first pieces that you decided to draw on your paper that we should probably have in our class model? What do we got? Okay, I need lightning. And how am I going to draw lightning, MJ? Oh, I need a cloud first. Okay, and then a streak. So let's start with cloud. Does everyone agree? I probably have a cloud here. I think most of us had that in our model. Cool. Cloud. Okay, cool. One cloud, or do I need more than one cloud? I need a lot of clouds? How many is a lot? I don't know, doesn't matter. Do we agree one cloud, or do I need a couple of clouds?
You need a couple.
You want 4? Great, I will draw 4 clouds. I need rain? You think so? Did we all show rain?
I didn't put it, but I think it's a good idea.
You didn't put it, but you think it's a good idea. It mostly happens when it's raining. Has anybody seen lightning happen without rain? But I should still put it? Should I put it and write a question? Does it matter?
Doesn't like rain cause
Hold on. Oh, you're right. I'm missing the lightning still.
Yeah.
Doesn't rain cause what, David?
humidity?
What do you mean by humidity again?
Humidity where particles.
Yeah, there's like a lot of like moisture, right? We don't experience that a lot here in Denver because of our elevation. We're a pretty dry climate. But when it's raining, it's humid out. There's a lot of moisture in the air. And what do we know about places where lightning happens the most? It's humid, like Texas and Florida. That was a noticing from last week.
Okay, so taking a look at just that video, I asked you to think about the teacher's role, the student's role, or how does the teacher move the students thinking forward? So if you could put into the chat a statement about any one of those 3 bullets, what did you notice about teacher's role, student's role, or how the teacher's moving the student thinking forward? Go ahead and add it into the chat and hit enter. Okay, so we have teacher facilitates a discussion. Good. Teacher uses a do you think so? Teacher sought agreement before posting in a consensus discussion. That's so important. Having an open-ended discussion. So it wasn't a right or wrong answer. There was lots of different thinking coming out in the discussion. Teacher's role is to ask leading questions and move the discussion forward. Good. Asking clarifying question. Asking questions to shape the model. So as teachers, we know where the models are going to land, but we need to ask questions to get the students there and get the model being built from the student voice, and allowing students to reach their conclusions mainly by posing questions, which is a different lane for us to be in as secondary teachers. It's a little uncomfortable at times. But once you get into using these talk moves and questioning as a strategy, you're going to find that you learn a lot about your students' thinking and know more about their thinking so that you can help them better reach the goal of understanding the science. So with that, we have about 4 minutes left in our time today. So I want to talk about the tools for productive discussions. And in the Talk Science Primer, near the end, there's the checklist for productive discussions and 9 talk moves. And I'll put the link for that document in the chat for you. There we go. So I'll put the link for it here in the chat so that you can have your own clean copy there. There you go. And what you'll see here are these goals, right? So 4 different goals. How do we help individual students share and expand and clarify their own thinking? And underneath here, you're going to see some prompts. They're teacher prompts, right? But they're also prompts that students could use with each other after you've modeled it with them. So we did a think, pair, share. So you had your quick write. So time to think, and then partner talk before you go to the big group, using wait time, asking students if they can say more or give an example, and then revoicing. Are you saying this? All of those can help clarify the students' thinking. Goal 2, help students listen carefully to one another. This is a nice way to get students who usually don't talk in class to say something that's low stakes. Can you rephrase what somebody else said, or can you repeat what somebody else said? And then help students deepen their reasoning. You're asking for evidence. I challenge folks every single time I'm out in schools to use how do you know that? What's your evidence? How did you get to that conclusion? And then a little higher level would be to use a challenge or a counterexample question. And then the last one, which is so important for discussions to happen and to ride on their own without you having to manage them, would be to ask students to agree or disagree, to add on, or to explain what somebody else means. And once you use these as part of your practice, the students will start using them as well. I took these little talk moves and I kind of boiled them down for what I'd like my students to use on their own, and put them on an index card on their desks and then also in their lab notebooks so that they would have some ideas of what to use when we're doing our class discussions. And then, so we've got those and the talk moves. We're not going to have time for the other 2 videos. I will share this this video on our website, not the video, the slide deck on our website, so that you can go back and check out these slides and also the recording from today. So with that, we have about a minute or so left. So think about your next steps as you're going into the classroom or going into your role for the fall. Plan your next discussion and keep the elements for productive discussions in mind. Give students the opportunity to do the talking and sharing their thinking. Ask questions with the goals for productive discussions in mind to facilitate the discussion, and use questions to move the students' science thinking forward. I will share the website for the presentation. That's going to be on our Activate Learning website. And let me grab that real quick. I'm going to stop the share so that I can poke around and get it. So I thank you for joining me this evening. It's been my pleasure. As I mentioned at the beginning of our presentation, if you have any questions or would like some follow-up, please don't hesitate to email me. I'd love to hear from you in the future. And with that, our time has ended. If you want to stay on and get the link for where the website's going to be posted, I'll be happy to share that in the chat. Have a great evening, everyone. We'll see you soon.